All right, here we are. Looks a lot like yesterday, except for this basketball player instead of this dragon people. So what's the purpose of this? Well, I chose to use the same problems from yesterday because I understand that there's a lot of frustration and a lot of confusion. The only difference with the challenge questions today is right here you can see that I have a yards to inches. So this is what we call the customary units. This is the one that's not quite as easy to convert. And then up here you have the metric system, which is just converting with decimals. Because when you convert these, it's all powers of 10. This is 10 of these are 10 of these are 10 of these are 10 of these. So hopefully you've already completed your challenge questions. And now your brain's like, whew, I need to figure out the problems that I got wrong. And if that is you, you're probably frustrated, but man, you're looking at this whole school thing and math thing the right way. That's how you get smarter. So let's check it out one at a time. A, looks like we are looking for the digit that's in the hundredths place. And remember, because it's THS, it's just like the fraction. It's smaller than one whole. It takes 100 to make a whole. Therefore, it's going to be on this side of the decimal because everything on this side of the decimal is going to be a whole number and everything on this side is a fraction. How do you know which one the hundredths place is? Well, remember, the trick is if you look at its fraction form, however many zeros it has, that's where it's located. So there's 2 zeros, so that means this is the hundredths place. So your answer should be 8. Okay, your answer should be 8. Let's go to B. It says convert into an improper fraction. Well, right now we have what we call a mixed number. Why is it a mixed number? Well, it's a mixed number because you have kind of two parts. You have a whole amount, and then after you have the whole amount, you have a little tiny amount that's not as big as a whole. So a whole number and a fraction is called a mixed number. We want to take that mixed number and just exchange it for change. Exchange it for an improper fraction. Why is it going to be an improper fraction? Because it's going to be bigger than one whole. Why is it going to be bigger than a whole? Because it's 9 and a fourth. So if we turn the whole thing into a fraction, it should be bigger than a whole. Right now you just have 1/4 and you have 9 wholes. So we want to focus on that fourth because to turn it into an improper fraction, we want the whole thing to just be fourths. So the first question is, how many fourths are in a whole? 4 fourths. If there's 4 fourths in a whole, how many total fourths are in 9 wholes? Well, you have 4 fourths, you have 4 fourths, you have 4 fourths, you have 4 fourths, 4 fourths, 4 fourths, 4 fourths, 4 fourths, 4 fourths. You have 9 4 fourths. So the first thing you do is you multiply. 36. So 9 wholes is worth 36 fourths, right? And then if you also have 1/4, you have 36 fourths and 1/4. So remember, after you multiply, you add. So total, we have 37 fourths. So turning this into an improper fraction, 37 fourths. And if you turn 37 fourths into a mixed number, you'd get 9 and 1/4. Okay. Ooh, now the conversion. Well, the first thing that we can do for the conversion problems is we can write our cheat up here. So we're working with the metric system. So I'm going to put King, Henry died, and then I'm going to put a blank, drinking, chocolate, milk. So now I have 7 different areas. I got kilo, hecto, deca, and then I have whatever we're measuring with, whether it's weight, length, or volume, deci, centi, milli. Okay? So now the first thing that we're going to do is M to km, which deals with length. It's meters. Everything's meters. So what's right here is M for meters, and what's over here is km. So we are starting with meters because we have 8,000 meters. We're starting here and we're going here. So we want to travel left 1, 2, 3 spots because meters is right here. Meters takes 10 and then 10 of these and then 10 of these. So it's 1, 2, 3. So it's 3 spots. So now I'm going to write my 8,000 down. And I'm going to move the decimal 3 spots left. Well, where is the decimal? Oh, it's a whole number, so the decimal's here. Move it over 1, 2, 3. Turns into 8 and 0 thousandths. Wait, 8 and 0 thousandths is a fancy way to say 8. 8. So your answer is 8. So 8,000 meters is equal to 8 kilometers. Let's go here. 250 milliliters to, I made the same mistake I made yesterday. Liters. So we're going to take 250 milliliters and turn it into liters. You can't go from milliliters to meters. It doesn't make sense. So milliliters would be right here because liters means that we're measuring liquid, right? And if we're measuring liquid, then all these have L with them too. So it's kiloliters, hectoliters, decaliters, liters, deciliters, centiliters, milliliters. So we're going from milliliters to liters. So we're going to go left, 1, 2, 3, left 3. So I'm going to write down my 250. It has an invisible decimal right here. I'm going to move it left 3. Turns into 0.25. And then you could say it's 25 hundredths. Whether you have a 0 here or a 0 here, it's still 25 hundredths. None of that stuff matters. So your answer there is 0.25. Now the one that we're all excited for. Yards to inches. Well, what do we know about yards and inches? We know that every 1 yard equals 3 feet, and we know that every 1 foot equals 12 inches. So we know that every 1 yard is 3 feet. So that means every 1 yard equals 36 inches. But we don't have 1 yard. We have 2.5 yards. Yikes. So if 1 yard equals 36 inches, I'm just going to put that right here. 1 yard is equal to 36 inches. And then over here, we have 2.5 yards. So if I have 1 here and I move over to 2.5, how many ones do I have? Meaning 1 times what is 2.5? And if you ever do not know this, you can divide to figure that out. That's 2.5. Do it to the top, do it to the bottom. We're going to get our answer with 36 times 2.5. Okay, so 36 times 2.5. We have a new problem here. 36 times 2.5. Whenever you multiply a fraction, you have to make sure they're in numerator-denominator form. So 36 over 1. And then 2.5, ooh, we got to turn it into an improper fraction. Each whole is worth 2 halves. So that's 5 halves. Can I reduce first? Sure you can. Do you know how to do that? If that answer is no, then multiply across first. If that answer is yes, you're going to know that I can count by 2's, cut them both in half. This would turn into 18. This would turn into 1. So now I have 18 times 5, which is 90. 1 times 1 is 1. So the answer is 90 over 1, which is 90. So So how many inches are in 2.5 yards? 90. 90 inches. If that did not help you out too much and you're still confused, it's okay. We'll talk about it again tomorrow and then the next day. So let's look at this problem. I tried to take away the fractions to make it a little bit easier. We have 3 feet, 5 feet, 1 foot, and then this whole entire thing's 9 feet. So we want to find area and we want to find perimeter. Well, let's first fill in this number right here and this number, because everything else we have. So this whole thing's 9. And then if this is its own rectangle right here, that's 5 on top, so that means it's 5 right here. And if this is 5, this must be 4, because 5 plus 4 makes you 9. And if this is 4, that means this is 4. And then this one's a little bit more difficult. This whole thing is 3, so that means this whole thing is 3. And if this whole thing's 3, this is 1, so this must be 2, because 1 plus 2 is 3. And if that's 2, then that's 2. So let's find the perimeter. The perimeter would be 5. Make sure I check these out. Because remember, when you make perimeter, you make the outside. 5 plus 1 plus 4 plus 2, and then the whole bottom's 5 plus 4, which is 9. We don't do this because this is not the real outside of the problem, right? This is me splitting it into 2 to make the area. So 2, 9, and then 3. So the perimeter is 5, 6, 10, 11, 12. 12 plus 9 is 21, 22, 23, 24. Let me double check my math. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Perfect. So the perimeter is 24 feet. And then the area, you find each area separately and then add them together. So the area of this block is 5 by 3, which is 15 square feet because it's two-dimensional. And then you have 4 times 2, which is 8. And if the area of this block is 8 and the area of this block is 15, add them together. 13, 23, and then the whole thing in feet, so 23 square feet. So that's the area, that's the perimeter. All right, let's move on to what we are learning today. Today, what we are going to learn is we are going to learn about, drum roll please, we're going to learn about a different dimension. So we have worked on length, right? One dimension. What is one dimension? Well, one dimension, it looks like this. It's just length. It's saying, hey, can you measure how long that area is over here? It's one measurement. That's the easiest way to describe length. It's one measurement. So you need like a measuring tape. And if you measure one length, then that's one dimension. If you say how many miles it is from here to Traverse City, that's a length. That's an example of one measurement. So an example of length right here on the screen would be from here to here would be a length, right? A one measurement, a one dimension, a length. What's two-dimensional then? Well, two-dimension is actually something that you can touch, okay? Two-dimension is something that you can touch. It's a flat surface. So my actual screen right here is an example of two-dimension. It is one measurement by another measurement. Length times width, that is a two-dimensional. How do you find how much space a two-dimensional object fills up? It's called area. You multiply one length by a width, right? So an area, so this is an example of a two-dimensional area, 1 by 1. So the area would be 1 cm squared because it's a two-dimensional object. So, all right, so one-dimensional is just the length or one measurement. An area would be two-dimensional. So it's a measurement by a measurement. What in the world would three-dimensional be? And that's what we're working on today. We're working on three-dimensional. So an example of a three-dimensional shape is right here, a Kleenex box, right? Why is it three-dimensional? Because it's one dimension, because it has a length, but it's one dimension by another dimension because it has a flat surface. And then that flat surface has a depth to it. So it's not just a flat surface, it's a flat surface that goes up and down, and it has an entire depth to it. In fact, you could fill it with something like these Kleenexes that I just destroyed. Because this is a three-dimensional object. And how do you find the measurement of a three-dimensional object? You find its volume. All you have to do is you find one side, because it doesn't matter how I have the shape, it still has its same volume. So what you want to do is you want to find one side, one flat area, and find the area of that, and then multiply that by how high up and down it goes, right? I used to get so nervous when I was younger. Which one's the width? Which one's the length? Which one's the height? And it took me until later to realize it doesn't really matter which one you call the length or the width or the height, because if I pretend that this is the base and I multiply length times width, and then I multiply that by height, then this is its volume. But what if I just stand it up like this, and then this is the base? Did its volume change? No, its volume didn't change. So then I would multiply this by this by this. Let's go over a couple of examples. Before we do that, let's talk about the parts of a cube, because a cube is your three-dimensional object. So this first box is pointing at the side, okay, the side, like right here. What are these called? What are these sides called? They're called edges, edges. So like if you were walking, don't jump off the edge. This has an arrow right here to this yellow portion. What would you call this yellow portion? What would you call the yellow portion? What would you call that? You call it its face. See? Faces smile, right? All right, and then what would you call this last portion? It's circling the vertex, which is corner. It's a fancy way to say corner is vertex. Now, let's talk about how you find the volume, okay? So how do you find the volume? The way to find the volume is you just want to focus on one of the faces. It doesn't matter which one, okay? Some people might look at the one that's on the ground, right? If this was a surface, the one that's on the ground is down here, which is the exact same thing as this one up here. So some people would right away want to focus on this one. So the measurement for this top part is 2 by 3. So what is 2 by 3? 2 by 3 is 1, 2, 3, 4, 5, 6. So the area of the top is 6. But the question is, how high up and down does 6 go? Well, 6 goes 1 up and down, 2 up and down, 3 up and down, 4 up and down. So the height of this is 4. So 6 doesn't happen once. 6 happens 4 times. And 4 times 6 is 24. So the answer here, the area, or I'm sorry, the volume is 24. And you could be like, well, let me count. 1, 2, 3, 4, 5, 6, 7, 8. No, do not count. They try to trick you by they want you to count the entire thing, but you can't see some of the cubes. So you got to use your imagination. So instead of doing that, you use the formula. Length times width times height. And all that really means is focus on one of the faces, and multiply the length times the width, like you're just trying to find its area. 2 by 3 would be an area of 6, and then multiply how high up and down 6 goes. The height, 1, 2, 3, 4, and 6 times 4 is 24. And you're like, oh, Mr. Stahl, earlier you said that I could use anything for the face. Yes, you can. Because if this, use your imagination now, was laying down like this, and this part was on the ground, would it change how much space everything takes up? No, it's still the same object. So if this was the base, it would be 3 times 4, right? The area of this is 3 times 4, which is 12. And then but now the height is now this, right? Because if this was laying on the ground, 12 would go up and down twice. And what's 12 times 2? 24. So it doesn't matter which face you call the base, you're just going to have to figure out what the height of that base is. Normally people multiply their first 2 numbers with the side that's opposite of the one that's on the ground, but it doesn't matter which area you choose to multiply. You just have to figure out what its height is then and multiply it by that. So that's the example of figuring out the volume of a cube. What if it's not a cube? I'm sorry, what if it doesn't have cubes in it? What if it's something instead like this? Well, same thing. See the one on the ground's right here. So pretend like nothing else is here and you're just finding the area of 15 by 6. So what's 15 by 6? Because it's 15 up and down by 6. Well, so if you don't know that, you can multiply 15 times 6. 5 times 6 is 30. 6 times 1 is 6, plus 3 is 9. So the area would be 90, but 90 goes up and down. It goes up and down 10 centimeters. So what's 90 times 10? 90 times 10 is 900. And because we're finding volume, you have a little tiny 3 because it's 3-dimensional, because you're multiplying length times width times height. And all that really truly means is 1 is this. So this is 1 unit, cubed, which is a little tiny 3, right? That's why we put a little tiny 3 up here. It doesn't mean you have to multiply this by 3 or anything like that. It literally is just telling someone I found the volume. It's 3-dimensional. All right, and that's what's going to do it for this session. That's going to do it for this session, and I will see you at 10:30.